Hello, so welcome to the answers. This should be, the first 8 should be fairly straightforward, and then we will go and take a closer look at some of the slightly more complicated ones that you may have got wrong, but don't beat yourself up about it if that's the case. So question 1, the answer was 18.016 grams per mole. Do not forget grams per mole. The second, calculate the molar mass of nitric acid, 63.018 grams per mole. Calculate the molar mass of Na2CO3, 105.99 grams per mole. You may have rounded that to 106. That is fine. Don't forget your units, and don't do what I do and change the units entirely by forgetting to put your -1. Calculate the mass in grams of BeO. So again, we should have got 7,003. Depending on your periodic table, this may have rounded down to 7,000. Question 5, 0.075 mole. Question 6, the amount of substance in mole. So again, we've used little m over big M, so real world over molar mass, and we have come out with 0.000083 mole. That can also be written as 8.3 times 10 to the -5 mole. Question 7, little m over n, so real world over number of moles, gives us a molar mass of 74 grams per mole. Question 8, little n times big M, so that's number of moles times molar mass equals 4.9 grams. Now, we're going to have a look at the next question. Now, you may have not noticed. If you have, well done. But if you look here, we have got kilograms. That means we have to do an initial calculation first, because remember, our triangle is in grams. So 0.2 kilograms is the same as 220 grams. Now we can go through it. So 220 grams over 44.02 grams per mole gives us 4.9977 mole, or 5.0 mole if we were rounding. Question 10 should be another straightforward one. Real world mass over number of moles gives us a molar mass of 28 grams per mole. Question 11, another straightforward one. Number of moles times molar mass, N times big M, equals 13.248 grams. Okay, so now we're getting to some slightly more complicated ones. So what we have got here is we have got brackets within the formula. Everything inside the brackets needs multiplying by everything on outside of the brackets, so in this case 2. So for question 12, what we've actually got is the molar mass that we are of CaOH2 equals the molar mass of Ca plus molar mass of 2 times oxygen plus molar mass of 2 times hydrogen, which equals 40.08 plus 32 plus 2.016, which equals 74.096 grams per mole. Then we can input that into the equation where we have mass over molar mass. equals N, and that equals 0.0004656 mole. There we go. Again, in this one, so we have got the molar mass of CaNO3 brackets 2. What we are asking for here is molar mass of Ca plus molar mass of 2 times N. Now we've already got 3 oxygens already, but now because we have got 2 on the outside of the brackets, everything on the inside of the brackets gets multiplied by 2. So we need the molar mass of 6, 2 times 3, times oxygen. Okay, so our sum for that is 40.08 plus 2 times 14.01 plus, and I'm going to put that in brackets so our calculator doesn't have a panic attack and give us the wrong number, 16 times 6. And that ultimately gives us 644.1 grams per mole. Then we can use this number in this sum here, because we've already worked it out for this one. We've got the same substance here, so we're going to use it for 644.1 times by 0.00455. Let's not forget our units. So this is grams per mole, and this is in mole, and that gives us 2.93 grams. Well done if you got all of those right. Take a look at the more difficult ones again. If you didn't quite get it right, if you're still struggling, drop me an email or catch me after one of the classes, and I will see if I can help you any further.